Welcome to the video for sections 3.2 and 3.3. Section 3.2 is on polynomial and rational functions. Before we jump into this, we're going to start by reviewing polynomial division. So my first example, I want to find the quotient and remainder when the first polynomial is divided by the second. So I'm going to set up my long division problem. I need to divide x squared plus 3x plus 3 by the polynomial x minus 2. To do this, I need to look at my first term in the divisor, first term in the dividend, and decide what do I need to multiply x by to give me x squared. Well, I would multiply that by x. So I'm going to put x up here, and I'm going to put it above the x to the first term in the dividend. I need my like terms to line up in columns so that when I go to add or subtract later, I'll be able to combine like terms. So I'm going to put x to the first directly above the 3x. And then I'm going to multiply back. So x times x is x squared, and that goes in the x squared column under this x squared. X times negative 2 is negative 2x, and that's going to go here in the x column. And just like with division when you're doing arithmetic, at this point you need to subtract. So I'm going to subtract x squared from x squared, and I'm going to subtract negative 2x from 3x. I personally find it easier to, when I subtract a polynomial, to just change all the signs, because that's all I'm doing. I'm just adding the opposites. So I'm going to put a negative here, and I'm going to change this one to a plus, and then I'm going to circle it so that my eyes know to look at this sign, and I know that I've done it, so I don't accidentally do it twice. So now I can add x squared plus negative x squared. That cancels out, and this should always happen in this step if you're doing it correctly. And then I'm going to add 3x plus 2x and get 5x. Okay, now just like with regular division from arithmetic, you're going to bring down the next term. So bring down your 3 plus 3. And now you're going to look at the first term in the divisor again and the first term in this new polynomial. What do I need to multiply x by to give me 5x? I need to multiply that by positive 5. So I would put plus 5, and now I've got it in the constant column. Multiply back. 5 times x gives me 5x. 5 times negative 2 is negative 10. I'm ready to subtract, so I'm going to change my signs, put a minus and put a plus here. 5x minus 5x cancels. 3 plus 10 gives me 13. Alright, this is my remainder. The question asked me to find the quotient and the remainder. So the quotient would be the x plus 5. The remainder is 13. And typically we can write our answer, if they had just asked us to give the polynomial, we would have said x plus 5 from the quotient plus the remainder divided by the divisor. So we have x plus 5 plus 13 over x minus 2. X plus 5 is the quotient, and 13 is the remainder. So that's the first one. Number 2, we're going to do the same way. In number 2, we need to divide 2x squared minus 5 by x plus 3. So I'm going to set this one up. X plus 3 is my divisor. My dividend is 2x squared minus 5. Now you'll notice this time you do not see an x to the first term. When we put this into the box for our dividend, we need to put a placeholder for that x to the first so that we've got a column for any of our like terms that have an x. So we need to say 2x squared plus 0x minus 5. So make sure you've got that placeholder. Just make sure that every power of x that's smaller than the largest exponent is represented, so that you would need a placeholder for any power of x that's smaller than what you're starting with here. And now we're ready to work through it. So x times what gives me 2x squared? Well, we need to multiply that by 2. 2x. So we'll put 2x in the x column. and multiply back. 2x times x is 2x squared. 2x times 3 is 6x, so that goes in the x column. Now I can subtract. I'm going to change my signs. 2x squared minus 2x squared cancels. Then I've got 0x minus 6x, so I get negative 6x here. Bring down the minus 5. X times what gives me negative 6x? I would need to multiply this by negative 6, so I can put minus 6 in my quotient. Negative 6 times x is negative 6x. Negative 6 times 3 is negative 18. Okay, I'll subtract, so I need to change my signs and add. My 6x's cancel. Negative 5 plus 18 is 13. So we can see that our quotient is 2x minus 6, our remainder is 13, and we could write it as 2x minus 6 plus 13 over x plus 3. So the quotient plus the remainder over the divisor. Quotient was 2x minus 6, and the remainder was 13. Alright, let's go on to, now we're ready to start section 3.2. So with polynomial and irrational functions, what we need here in this section is the remainder theorem. The remainder theorem states that if r is the remainder when a polynomial p of x is divided by x minus c, then r equals p of c. What this is actually saying is that if you divide a polynomial like we just did, like we did, like in number 1, we divided by x minus 2. Okay, so if we look at that constant 2, and we just look at the number, so not the minus, but just the 2. If we were to evaluate this by putting 2 in for x, so if we were to find p of 2 here, substitute 2 in for the x, that would give us 4. So if I were to do that, it would give me 4 plus 3 times 2 plus 3. 4 plus 6 is 10. 10 plus 3 is 13. That's going to equal the remainder that we got when we divided. So evaluating that polynomial for this constant here will give you this remainder. That's what the remainder theorem is saying. So in example 1, we're asked to use the remainder theorem to find p of 3. So that means we want to divide this by x minus 3. So to divide this by x minus 3, we'll set up our division problem. Put our coefficients inside, so we've got 2x cubed minus 5x squared plus 4x minus 6. X times what gives us 2x cubed? I would need to multiply that by x squared. So again, you're just looking at the first term and the first term. Multiply this by 2x squared, so that's going to go in the x squared column. Then we'll multiply back. 2x squared times x is 2x to the third. 2x squared times negative 3 is negative 6x squared, so that goes here. I need to subtract, so I'm going to change my signs and add. So these cancel. That gives me 1x squared. Bring down the 4x. Now look at the first term and the first term. What do I multiply x by to give me x squared? I need to multiply it by x, so that's going to go here. X times x is x squared. X times negative 3 is negative 3x. Now I change the signs and add, so that's negative, positive. These cancel. This is going to give me 7x minus 6. And then I need to decide x times what gives me 7x here. I would multiply that by 7, so that goes up here. 7 times x is 7x. 7 times negative 3 is negative 21. Change the signs and add. My x's cancel. And then here I'm getting 15 for my remainder. So 15 is the answer. The remainder of 15 is my answer this time. We could check this, of course. You could go back and substitute in 3 for x all the way across, and that will also give you 15. So that's example 1. You may be asking yourself, why would we do it this way when it's so much easier to just plug in the 3 up here? Well, there are going to be times where it's going to be easier to do division. We're going to learn synthetic division, and synthetic division gives you a shortcut, a faster way of doing some polynomial division problems. And in certain cases, it may be easier to use the division rather than substituting in, just depending on the degree of your polynomial. Example 2, we find the quotient and remainder when x squared minus 5x plus 7 is divided by x minus 2. So we're going to, x minus 2 is my divisor, x squared minus 5x plus 7 is my dividend. What do I multiply x by to give me x squared? That would be x. And it goes in the x column, so x times x is x squared. X times negative 2 is negative 2x. Change the signs and add. So that's negative 3x plus 7. Alright. X times what gives me negative 3x? That would be negative 3. Negative 3 times x, negative 3x. Negative 3 times negative 2 gives me 6. Change the signs. The x's cancel. 7 minus 6 is 1. So our quotient was x minus, so we can write this as x minus 3 plus 1 over x minus 2. X minus 3 is my quotient, and 1 is my remainder. Alright, now let's look at synthetic division. Synthetic division is a shortcut method for polynomial long division. Synthetic division cannot be used in every situation. It can only be used if you're dividing by x to the first power. So if you're asked to divide a polynomial by x squared or x cubed, synthetic division does not work. But in this case, dividing by x to the first, it does. And when you can use it, it really is very, very useful because it really does shortcut the process. The way it works is we're going to draw a box like this, like an upside down box, and we're going to look at all the coefficients that we were given in this polynomial. We're just going to eliminate the variables and only work with the coefficients. So we need to put 2, negative 5, 4, and negative 6 in the box. Okay. Then we're going to look at the x minus 3, our divisor. We're going to ignore the x and just look at the constant. Alright? Now, because if you remember how in the long division problems that we did earlier, how you had to subtract every time and we had to change the signs and add to make it easier, in synthetic division we're going to change the sign on the constant and then we can add throughout the problem. So instead of putting a negative 3, I'm going to put a positive 3. And I'm going to draw a line here. And then I'm going to start with the first term. The first one comes straight down. So just bring down the 2. So I'm going to put some arrows in here the first time. Maybe that'll help you. Then I'm going to multiply 3 times 2 is 6. So 3 times 2 is 6. And it goes here. And then I'm going to add negative 5 plus 6 gives me 1. Then 3 times 1 is 3. And that goes here. Add 4 plus 3 is 7. And then multiply 3 times 7 is 21. It goes here. And then add negative 6 and 21 and we'll get 15. This last number is the remainder. And the quotient is going to be the polynomial created using these coefficients. to figure out how to start the polynomial, is the degree is always going to be 1 less than the degree of the original polynomial, because we're dividing it by x to the first. So if you started with 2x to the third, your quotient will start with the x squared. So the quotient is going to be 2x squared plus 1x plus 7. The remainder is 15. So you can write it as plus 15 over the divisor x minus 3. So that's the quotient here, and 15 is the remainder. So you might want to watch that again if you need to see the process again, but we are going to do more examples. Example 4, use synthetic division to evaluate the polynomial. So you see this, g of x equals x cubed minus 3x squared plus 5x minus 12, find g of 4. Your first instinct is probably to just start plugging in 4 for all the x's. But we're asked to use synthetic division to do this. So we're going to set this up. We're in our upside down box. Okay, if we evaluate this at 4, that's like if you're dividing it by x minus 4. So the 4 is going to be the constant. I'm not changing the sign on this because that's the actual x value that they want me to use. So I'm going to divide it by just 4. And then I'm going to put my coefficients in 1, negative 3, 5, negative 12. Alright, so I'm going to put my line. Bring down my 1. 4 times 1 is 4. Put it here. Negative 3 plus 4 is 1. 4 times 1 is 4. That goes here. 5 plus 4 is 9. 4 times 9 is 36. Negative 12 plus 26 would give me 24. This is my remainder. Okay? Now we know from the the remainder theorem, that the remainder that we're getting here is the actual answer for g of 4. So 24 is our answer. Now you could check that on your own. You could put 4 in for the x's, and you should get 24. Example 5. Is x plus 4 a factor of x cubed minus 13x plus 12? If so, factor completely. So we're going to do another synthetic division problem. This time we're being asked to decide if our trinomial can be evenly divided by x plus 4. So if I were to do a long division problem, x plus 4 would be my divisor, and then the trinomial would be my dividend. So we could put, out here we're going to be dividing by negative 4. Alright, so why did I change the sign this time when I didn't in the previous one? Because in the previous one, they told us to use just plain 4. This time, they're asking us to check to see if x plus 4 is a factor. So if x plus 4 is a factor, and you were to solve it for x, you would end up with a negative 4. So this is when you have to change your sign. So we're going to put in our coefficients. We need a 1. Alright, notice there's no x squared term this time, so this is where you need to put in a 0 for a placeholder. Then you need a negative 13 and a 12. Alright, I'm going to bring down my 1. Negative 4 times 1 is negative 4. Add, I get negative 4. Multiply negative 4 times negative 4, that gives me 16. Negative 13 plus 16 is 3. Negative 4 times 3 is negative 12. 12 minus 12 is 0. So we got a remainder of 0. Well, a remainder of 0 tells me that x plus 4 divided evenly into this trinomial. So that means we can say yes, it is a factor. So yes, x plus 4 is a factor. Okay. We're also asked to factor completely. So since x plus 4 is a factor, we can write it as x plus 4 times, the quotient we got here would be x squared minus 4x plus 3. And then we need to factor this trinomial, so we have x plus 4. And then this factors as x minus 1, x minus 3. So my answer is x plus 4 times x minus 1 times x minus 3. So all we did was we did synthetic division to determine if x plus 4 was a factor, and then we got this trinomial, and we finished factoring the trinomial to get this. Okay, next we want to talk about the rational root theorem. Alright, the rational root theorem, there's a formal definition of this in the textbook, but I'm going to paraphrase it just by showing you an example of how it works. If you're given, let's say you're given a polynomial, but instead of it starting with x to the third, it might start with x to the fifth, and you're asked to solve it or to find the zeros or the roots. Factoring is not really going to help you in the beginning. What you need to do is find something, use synthetic division to find something that will go evenly into it. But how do you know where to start with your synthetic division? The rational root theorem gives you like a starting point. And it just states that all possible zeros of a polynomial would have to be limited to the factors of this term, which we call p, which is a constant, divided by all factors of the leading coefficient q. So in this example, you will look at all possible factors of 6 and 2, and then you would do it as a ratio. So if we look at all possible factors for 6, you could do plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. All possible factors for q, which is the 2 here, will be plus or minus 1, plus or minus 2. All possible zeros that might work for this thing would be limited to the ratio of these values divided by these values. So all the p over q's. So that would be plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, plus or minus 6 over 1. So that gives me these whole numbers. And then plus or minus 1 over 2, plus or minus 2 over 2, which is the ones that we already have, plus or minus 3 over 2, and plus or minus 6 over 2, which is 3. So this would be a starting point to help you know how to begin your synthetic division. So all possible zeros, that means all the values that would go evenly into your polynomial would be limited to these possible factors. So that does help to narrow down the possibilities. So we're going to use this in our next example. Example 6. Find all real and imaginary zeros for the polynomial function v of x equal x to the fourth plus 2x cubed minus x squared minus 4x minus 2. So let's look at p over q. P is going to be the constant, negative 2. Q is the leading coefficient, which is 1. So what are possible factors for these two numbers? Well, for p, you could have plus or minus 1, plus or minus 2. And then for q, plus or minus 1. Those are the only ones that that are possible here. So you would look at all possibilities for p over q. So plus or minus 1 divided by plus or minus 1, which is plus or minus 1. And then plus or minus 2 divided by plus or minus 1. So that's plus or minus 2. So when you do the synthetic division, whatever will go evenly has to come from these possibilities, from this list. So we're going to, it might take some trial and error for this, so I'm going to grab another sheet of paper because I might have to do a few of them before I find the one that works. So I'm going to do synthetic division. I'm going to put my polynomial coefficients inside for the divisor. So 1, 2, negative 1, negative 1, and negative 2. And then let's say I want to start with positive 1. Alright, so I'll try and see if positive 1 works. So it goes out here. Alright, bring down this 1. Multiply, 1 times 1 is 1. Add, that gives you 3. 1 times 3 is 3. Negative 1 plus 3 is 2. 1 times 2 is 2. Negative 1 plus 2 is 1. 1 times 1 is 1. And then add here, that gives me negative 1. So is 1 a 0? No, because it did not go evenly. My remainder was not 0. So 1 is not going to work. I'm trying to remember. I did this earlier, but I don't remember which one actually worked. Okay, let's do negative 1. But you might have to do multiple ones till you find the one that actually works. If I do negative 1, I believe negative 1 is the one that works. So I'm going to put it over here. And I'm going to put inside 1, 2, negative 1, negative 4, negative 2. Bring down the 1. Negative 1 times 1 is negative 1. 2 minus 1 is 1. Negative 1 times 1 is negative 1. Negative 1 plus negative 1 is negative 2. Negative 1 times negative 2 is 2. Negative 4 plus 2 is negative 2. Negative 1 times negative 2 is 2. Negative 2 plus 2 is 0. So because we got a remainder of 0, then this is the one that works. So negative 1 is a 0 or a root of this polynomial. Alright, so that's a good start, but we still got some more work to do. We found that negative 1 works, so we know that we can begin to factor this by writing it as parentheses x plus 1 times, and then this polynomial down here, so that would be x cubed plus x squared minus 2x minus 2. Alright, so you may be confused about why I wrote x plus 1 when I divided by negative 1. Okay, but we know from earlier work that if you've got, let me put this up here for a second, if you've got a polynomial and it factored as x plus 1 times x minus 3 equal to 0, you know that x plus 1 equals 0, x minus 3 equals 0. And you solve that, you get x equal negative 1, x equal 3. So we determined that we had a negative 1 that was a root, so that means the factor would have to be x plus 1. So that's why the sign changed, because you're going from this backwards to this step. So our factor is x plus 1. And then this is the remaining polynomial that we need to continue to factor. Now this has 4 terms, so I would want to try the grouping method on this piece of it. Or if you wanted to, you could look for another number that would divide into this. But I'm going to go to the grouping method. So bring down the x plus 1. Here you've got a common factor of x squared. So I'm going to factor out x squared. And that leaves x plus 1. Over here I've got a common factor of negative 2. That leaves x plus 1. I'm sorry, it's getting a little squished over there. Now I've got a GCF of x plus 1 that I can factor out. So I'll have this x plus 1 comes down. And then I'll take out x plus 1 times x squared minus 2. Or I could write this as x plus 1 quantity square times x squared minus 2. And because we're solving this, we need it equal to 0. Okay, so we have found that x plus 1 equals 0, or x squared minus 2 equals 0. So we've got x equals negative 1, and then over here you can add 2 to both sides and take the square root. X equals plus or minus the square root of 2. So those are our roots. Those are all the real or imaginary roots. So we got all real ones. So we got negative 1, negative square root 2, positive square root 2. And this is the way you would need to enter it into your homework as a solution set. So if you need to go back and watch that one again, I mean, that might be a good idea for you. At least you can go back and review it if you need to. All right, what about part B? Same question, find all real and imaginary zeros for the polynomial function. So we're given x cubed minus 9x squared plus 26x minus 24. So if we start by looking at the p-value, the p's from negative 24, what are all possible factors of negative 24? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12, plus or minus 24. All right, and then the q's comes from this coefficient, the leading coefficient is 1, so q has plus or minus 1. But as you can see, this is a lot of things to check with synthetic division. It may become too time consuming to do it this way. Sometimes this method is helpful, and other times it's there still leaves a lot to be checked. But remember, we're looking for roots of this polynomial. So these are values of x that would make the function equal to 0, or values of x when y equals 0. So at this point, it's perfectly acceptable to go to the graphing calculator and help you narrow this list down. So in my calculator, I want to type, so I'm going to go to the y equals button here. I'm going to type in the polynomial that we were given, x to the third minus 9x squared. Oops, I pressed something wrong. X to the third minus 9x squared plus 26x minus 24. Okay, you could look at the graph, but you could also go to the table of values. So you can go second graph to get to table. So second graph will take you to the table of values for this. And the numbers that you're needing are the numbers of x that will make the y equal to 0. So if you scroll down, you can see that when x equals 2, y equals 0. So that means 2 is a root. When x equals 3, y equals 0. When x equals 4, y equals 0. So we found the answer using the calculator, but we still have to back up our work with the algebra. So we've got 2, 3, and 4 are the zeros according to this. 2, 3, and 4. All right, now let's do it using synthetic division. So we're going to set up our division problem and just choose one of these. I'll start with a 2 and put the coefficients in. So you've got 1, negative 9, 26, negative 24. Bring down the 1, multiply, that's 2. This is negative 7. 2 times negative 7 is negative 14. 26 minus 14 is going to give me 12. 2 times 12 is 24. We're getting a remainder of 0, so that's exactly what should be happening based on our results on the calculator. So we have found that x minus 2 is a factor. So we have x minus 2 times x squared minus 7x plus 12. This trinomial can easily be factored. So you've got x minus 2, and then that's going to be x minus 3 times x minus 4. Set it to 0 and solve this. So you can see you're going to get x equals 2, x equals 3, x equals 4. So the calculator is, of course, use it as a tool to help you, but still make sure you back up your work. All right. And then moving on to the next one. So we're almost done. Section 3.3 I'm going to talk about, but we don't really, there's not a tremendous amount of material for 3.3 that you need to cover. In 3.3 we do need the Conjugate Pairs theorem. That's important. It states that if p of x equal to 0 is a polynomial equation with real coefficients and the complex number a plus bi is a root, then a minus bi is also a root. So basically, if you're told that you've got a root of, let's say, 2 plus I, then by this theorem you immediately know that its conjugate 2 minus I will also be a root. Okay, so conjugate pairs. So roots for complex numbers, the roots come in pairs with conjugates. So let's look at example 1. Find a polynomial equation with real coefficients that has negative 2 and I as roots. All right, if it has negative 2 as a root, then that means it has a factor of x plus 2. Okay? If it has I as a root, then that means it has a factor of x minus I. By the same logic that we used for the negative 2, we know that x plus 2 is a factor, and x minus I is a factor. And by the conjugate pairs theorem that we just saw, if I is a root, negative I will also be a root. So we can put the factor for it as x plus I. So these equal to 0 gives us our equation. So x plus 2 times x minus I times x plus I equals 0. And we can expand this out to get our equation. Now because these two are conjugates, I would combine those first. We know that when we multiply conjugates together, we're going to get the square of the first term minus the square of the last term, like that. And then we've got the x plus 2 over here. Okay, just because these are conjugates, we know that they're going to combine like this. So now we have x plus 2 times x squared. I squared is negative 1, so if you subtract negative 1, you're adding 1. And then we can FOIL this together to get the polynomial in standard form. So from here, we're going to do, and I apologize, this is a little bit squeezed in here, but foiling this, we'll get x cubed plus x, and then the inner would be 2x squared plus the last would be 2 equals 0. And if I put it strictly in standard form, I've got x cubed plus 2x squared plus x plus 2 equals 0. That's my answer. Okay. And just a little bit more. The degree of a polynomial is the largest power of x. So in this one, we've got f of x equal 3x to the fourth minus 2x squared plus 3x minus 5. The largest exponent is your degree. So that's easy. Multiplicity is the number of times a given root appears. So in this example, f of x equal x plus 2 to the third times x minus 1 to the fourth. The roots of this, the values of x that will make this function equal to 0 would be negative 2 here and positive 1 here. Okay. Well, negative 2 has multiplicity 3, because if you were to expand it out, you would have x plus 2 times x plus 2 times x plus 2. Set each one of those to 0, and you get a value of negative 2 3 times. So this exponent gives you the multiplicity for that factor, or for that root. So negative 2 has multiplicity 3, and positive 1 has multiplicity 4. And that's it. That's it for that section. So that's the lesson for 3.2 and 3.3. As always, email me any questions that you have about this, and good luck as you work through your assignments. Thank you.